Hi everybody, welcome to another general interest Sharcnet webinar. The topic today is programming with Witty, C++ Web Toolkit. My name is Armin Sovani and I am with Sharcnet based on University of Ontario Institute of Technology. And this is my email here. So if there is a question in your mind after this talk is over, you can contact me directly. Today, first I introduce Witty and its features, then I demonstrate a typical publicly available web application that I developed myself using Witty to give you an idea of what you can achieve by programming with Witty. Next, I walk you through the step and the installation procedure on different platforms. Once we have our Witty setup ready, we develop our first bare bones web application as a hello world. Then by learning about signals and slots, we start to add more functionality and making it interactive. If we have time, I walk you through some interesting examples in Witty's widget gallery. At the end, I introduce some Witty variants for those of you interested in other programming languages. For this webinar, I have to assume that you have a little bit of familiarity with C++ programming, but no experience in HTML, cascading style sheets, or JavaScript is necessary. So let's first see what is Witty and what you can do with it. Witty is a free and open source widget-centric C++ library and application server for developing web applications. It brings the desktop programming model to web application development, and for a programmer, the Witty API is similar to libraries such as Qt, which is written as Qt but usually pronounced as Qt, GTK, WX Windows, and Microsoft MFC. However, instead of rendering widgets to Windows or X11 Windows, Witty renders the widgets in web browsers. As a programmer, you develop your web application using Witty in C++, from which the library generates the necessary HTML or XHTML, JavaScript, CGI, or AJAX code. And if available, Witty will use JavaScript and AJAX, but it supports fallback mechanism for maximum browser compatibility. Browser-side events such as button clicks, mouse movements, and drag and drop events are transparently converted into server-side events using signal slot mechanism. Witty is a mature, robust, and feature-rich, well-documented, and well-supported library and has a very supportive community. So in case of problems, you can use the Witty website. And the support system is using the Redmine project management software. Okay, let's start with some checking the features that you can find in the Witty library. First, let's start with core library. The core library supports major browsers like Firefox, Internet Explorer, or Chrome, and etc., but also plain HTML browsers and web crawlers like Google search engine are also supported. You can develop and deploy on Unix, Linux, Mac, or Microsoft Windows environments. And by using graceful degradation or progressive enhancement, the behavior is equal no matter support for JavaScript or AJAX exists or not. It's really efficient in rendering the website, and it supports Unicode and localization. It also supports browser history navigation like back and forward buttons and bookmarks, and also clean URLs, which is really good for search engines like Google are also supported. And the next thing is event handling. Witty supports type-safe signal slide API for responding to events. It's like the Qt library, if someone has some experience with that already. The signal slot is exactly similar to Qt in the Witty. It listens for keyboard, mouse, focus, scroll, or drag and drop events and get event details. It also automatically synchronizes from field data from browser to server and tracks server-side changes to be rendered in browser. In case that the HTML CGI, because it's a progressive thing, if Ajax is available and JavaScript, it uses that, but plain HTML CGI and also WebSockets are also available. One good thing about the Witty is the native painting system. Witty has a unified 2D painting API which uses the browser's native graphics support. It also has unified GL-based 3D painting API which uses WebGL in the browser or server-side OpenGL. When a browser does not support WebGL, like Internet Explorer 10, Witty provides a server-side fallback. The image will then be rendered in the server and sent to the browser as a ping image. Interaction is still possible, but the performance will be determined by the network latency. You should also note that for practical scenarios, this requires a server with hardware 3D acceleration. There is also a rich set of 2D and 3D widgets also available that now I'm try to demonstrate some of those 3D charts for you, if I can. Okay, this is a typical example of a graphics and charts and paintbrush. This is a sample Witty program. Here you can use your mouse to draw different things here, and you can see here the complete C++ code that generated this web application here. Also, you can see these 2D charts here, as you can see, and the code that generated that. These are fully interactive charts. For example, here in pie chart, as you can see, as soon as I change one of the values like this to something else and entering it, it redraws the whole thing, and as you can see, it's really efficient and quick. And the whole source code that generated this is here. It is 3D paintings is also available. So to show an example, here I show you this 3D fully interactive chart, and this is the source code, complete source code that generated this chart. And this is another 3D category chart that is fully interactive to users. And also you can see the whole Witty source code that generated that. So one of the good things about the Witty is that it has out-of-the-box security. It supports kernel-level memory protection, which protects against privacy issues arising from programming bugs, and also supports encryption and server authentication using secure socket layers or SSL, and also transport layer security through HTTPS. If you use HTTPS, all the connections between the client and server will be encoded. It also supports built-in cross-site scripting prevention. Render text is always filtered against potentially malicious code, making XSS attacks against Witty application close to impossible. It is not vulnerable to cross-site request forgery or CSRF because cookies for session tracking are optional. And even when used, they are never solely relied for requests that trigger event handling code. It's not vulnerable to breaking the application logic by escaping to a particular URL, since only those events exposed in the interface can be triggered. And session hijacking mitigation and risk prevention is also supported. It also includes denial of service attack mitigation. There is also a built-in authentication module, which is good for getting user interface, user information, and it supports third-party identity providers using O authorization version 2 and later OpenID Connect. One good thing about the Witty is that it's already included an object relational mapping library called Witty DBO. It's a self-contained library which implements object relational mapping and is a convenient way to interact with SQL databases from C++. This feature is important because most serious web applications usually require a database backend. DBO maps many-to-one and many-to-many relations to STL-compatible collections. It provides a schema generation. Each session tracks dirty objects and provides a first-level cache. It has a flexible querying which can query individual fields, objects, or tuples of any of these using Boost Tuple. It comes with SQLite 3, Firebird, MySQL, and PostgreSQL backends, and an Oracle backend is also available on request. One feature that is really good during development of software using Witty is that the unit testing is really feasible. With Witty, event handling code constructs and manipulates a widget tree, which can easily be inspected by test code. Therefore, a WTest environment, which is an optional class in Witty library, allows your application to be instantiated and events to be simulated in absence of a browser, which is good for unit testing. One important concept in deployment of Witty is the connectors. The library provides two ways of developing applications, either using the fast CGI protocol in combination with a web server that supports fast CGI protocol like Apache, or using a built-in web server, which is called Witty HTTP daemon. Each of these two choices correspond to a library that is called connector. So in Witty library, there are pre-included connectors. One is built-in HTTP daemon, the other one is fast CGI, and the last one is IS API that is integrated with Microsoft Information Server. The built-in web server is more convenient during development and debugging because it's easier to set up. But the fast CGI-based solution provides more flexibility for deployment of the application. The built-in web server runs all sessions in a single process, while the fast CGI-based solution allows different deployment schemes, including dedicated processes per session. Thus, to build the Witty library with built-in web server, you need to link against libwt and uh, FCGI that I'm going to cover later when I'm developing our Hello World application. Uh, on that example, we usually use the built-in one, which is more convenient. As I told you, there is also an IS API connector available for Microsoft Internet Information Server, but it is only available for Windows platform. About the licensing, Witty may be used using either an open source or commercial license. If you wish to use the library using the new general public license, you may build a web application with Witty and deploy it. But based on the terms of the GPL, you should make the source code available to anyone who you give the application for installing on his own server. In other words, if connecting to a public server is the only way to run your application, there is no need to make the source code available. But for the commercial license, there is no such a limitation. Now I'm going to demonstrate a typical publicly available web application that I developed myself using Witty. You can access it using the following URL here, pelebsc.es. This is a complete web application that I developed myself for Barcelona Supercomputing Center using Witty. As you can see, it's a fully interactive website that is completely written in Witty. The good thing about it is that the whole functionality of the website is like ordinary web server, but it's not a page-centric one. The whole thing is one executive application that runs, and as soon as you click on each of these sections, the web page generated on the fly by the program. So if I go to About, the program generates this page on the fly, but the good thing is that it also tracks the back and forward buttons. So here, as you can see, it uses the clean URL for the help, and as soon as I click on back, I can see also about. But it's the program that generates these pages. And it's a fully functional web that allows users to register and log in using these dialogues. So I'm going to log in. And as soon as I log in, I can monitor all the jobs for this special application, because this application is developed to submit molecular Monte Carlo simulations to the server and then monitor the running and those things. This is a job that I previously submitted to the server, and as soon as I click on that, I can see their chart that shows the simulation, and it also generates these charts in real time while the job is running. This is already submitted job, so it's already finished, but you can also add a new job, and as soon as the job starts to run on the compute cluster, it shows the running simulation. But the good thing is that these charts are interactive to user. So you can, if you, for example, want to plot the column 1 versus column 5 here, the only thing that you should do is to change here to column 5. So as you can see, as soon as I change it to column 5, the chart changes. And you can also enable or disable each of these charts. And you can also change the resolution. For example, if I want to have a bigger chart, or focus on different area in the chart. For example, to pick this plot between the 200 and 300, I can change this and say OK, between 200 and 300. And as soon as I do that, it refreshes the chart, and now you can have an idea when we say interactive web pages or applications is like this. Okay, now I exit. And also in the examples, one good thing again is that if you want to include some videos, the good thing is that no matter which video format supported by the web browser, the Witty tries to have the best one. If the Flash supported, it gives that. So by putting your videos like this there, no matter which kind of videos is supported by the web browser, there is a high chance that it's working. Let's start with the installation process. For building and installing the latest version of Witty, you need at least CMake utility version 2.6 or higher, and also Boost C++ library version 1.41 or later. Older Boost versions may also be used, but some functionality will be missing. For example, JSON parsing and something like those. These Boost libraries mentioned here are not headers only and are needed to be linked depending on the usage. So depending whether you use some of the features in Witty, during the link phase, maybe the program, maybe it's necessary to link or add these libraries for the linking phase. There are also some optional packages that, if they are available, additional features will be enabled in Witty. For example, if OpenSSL available, then the HTTPS protocol will be supported by the web client and web server. But it's only necessary when you use the Witty HTTP connector, because for the fast CGI connector, the SSL protocol must be supported by the Apache. And also libharu, which is rendering support for PDF. If it is available, there is a PDF image paint device that is included, and you can render directly to PDF documents. And also graphics magic, if it's available, you can have a paint device that which outputs directly to raster images like ping or GIF. Pango is for text rendering of true type fonts. So if you want to have a better support for true type fonts, especially in your PDF documents, you can add this library too. And depending on which kind of database backend you want to use, you can also you should have the PostgreSQL or MySQL or Firebird in your setup. But the last requirement is depends on the connector that you want to use. If you want to use fast CGI, which is also only available on Unix platforms, you should have the Apache 1 or 2, and also MOD fast CGI module in Apache must be already functional and there. For built-in HTTP daemon, Witty HTTPD, you may need also libc for compression over HTTP, and also OpenSSL for HTTPS support. And you should also have ISAPI if you want to compile the Windows version. So for Unix platforms, if you are on Ubuntu, recent version of Witty is in the official packages. So using the apt-get, you can this command you can get it. But for other distributions and also Mac OS, the best way is using um, uh, the repository in Git and using this sequence of commands that I'm going to demonstrate now. The most important step in building the library using CMake is the CMake manual configuration. I mean this step using CCMake, which I try now to demonstrate it. Okay, the first step for building the Witty library is to get the latest source code from the Git repository. After that, it's going to be in the Witty folder, which then change to Witty and make a directory named build, and then change to that directory. And now we can CMake like this. But the most important step is the next step, because if you start to make with the default options, it's not going to make. So we configure CMake using ccmake dot, and now we can change the parameters that we want. One of the things that I usually recommend is that if you have the super user access to the system, it's really good to change the install prefix to USR just /USR. By doing that, because Witty is a library, the whole library can be linked directly, and system can have know already where is your dynamic link libraries. But if you choose another folder here, like USR local, it's important that later you add the path to the LD library path and then run ldconfig as a super user. For this time, I only use a /USR, and if you want the debug version also, you can include it here by on or off. Here you can say which kind of database backend you want. MySQL is on, and also OpenGL is good, but you can off some of these things, for instance, if you don't want them. And one important step here is the example connector. If you want to run the examples that is already made, it's better to use the Witty HTTP connector for that. And these are other things that you can change, but the most important one was the path of the library and also the connector. I disabled the FCPG fast CGI connector usually if I don't want to include the Apache one. And after doing that, you can press C to configure, then E, and then press G to generate and exit. Now you can first make the library, and especially if you choose a system directory like a /USR, it's important to sudo to the super user and then make install. So after this step, which I stop it, You can type, and the building process complete, you can type make install to install in the directory. After the install, because I've already done that, the building process takes about, I don't know, 10 minutes. I already done that, and when you, for the directory, I chose USR local lib. If you do that and then go to Witty directory, all the examples are here. By changing to the examples directory, you can run examples and check them. For example, here I run one of the samples. Let me try the WebGL one. Here, after building the library with examples, you can have the complete executive here by just running WebGL and enter. You can run the standalone server. As you can see, when you run a standalone server, my pointer is not good here, but the complete web server log comes to your screen, but you can redirect it if you want. So as you can see here, the web server is started and ready. The next step is running a web browser, and as you can see, the default port is 0.00, and the default IP address is 0.0.0, and the default port is 8080. So by connecting to that, here, I have it already here. You can see the WebGL example here, which is interactive. And here you have the shaders, fragment shader and vertex shader, that you can change them and see the results. For example, if I change the ambient light here to something else, like I change this one to 8. By updating the shader, you can see the results. Okay, as you can see, the color changes. Okay, if you want to build the Witty for the Windows, I recommend to use one of the binary packages which are available both in zip format and also executive format from here, this side, and install it as it is, because it gives you a head start using that. Now we started the Hello World application, but for that, because there is a really big similarity between the concept of Witty and Qt. First, let's see a typical Hello World example in Qt World. This is the minimal code to generate a Hello World application in Qt. As you can see in the main, there is a class Q application, and you define a Q push button with the text Hello World, and then say that the button must be showed. And then you run the application. This is the final result of that. But in the Witty world, as you can see, a typical Witty application requires more boilerplate code to get started than Qt. All headers are in Witty folder, as you can see. So, like Boost library, you should include WT before each header, and there is no extension for header files like STL. So if you want to use the push button, you only use the W push button as a header. Unlike Qt or Qt, the whole Witty library defined in Witty namespace. So you should using namespace here. And also you may note that all the classes in Witty start with W, like the Qt that starts with Q. In the main, we have a wrun. That wrun is a utility function that by passing a factory functor here, which is here is create application, runs the main Witty application and enters the main loop of Witty. And this is the definition of our application class, hello application, which is derived from W application. As you can see, it only has a constructor here. And the only thing that we should do in our constructor is to add the widget, which is W push button hello world, to the widget tree. The function root, which is a member function of W application, returns the widget tree of the whole application. So by having the root, you can build the hierarchy of all the widgets that are included in your application. And then later, you can access them or process them. So after having this in a file like hello.cpp, the command that we should run to compile is g++ hello.cpp-hello. But we should link with two libraries. One is the main Witty library, which is here. And because for this example, we are using the standalone web connector, we use the Witty HTTP library. Next thing, after the compilation is done, for running the application, we just do it like this, but because we use the standalone server, there are some parameters that we should specify. Okay, here I have the application already compiled. If I use the switch help, it shows all the parameters that is available, and as you can see, you should specify the document root, which must be the same directory as dot, and also at least you should specify the web server IP address and also port number. So for running that, I should use doc root and then HTTPS address, which is 0000, and then HTTP port, which must be, I say, 8080. And sorry for that. Okay, I have a mistake here. By doing that, the server is running, and here, if I refresh the website, we have the result, which is really simple. A hello world button that by clicking on that, nothing happens. So in next step, we try to put some functionality by having signals and slots. So a signal is a message that an object can send, most of the time to inform of a status change. And here, for example, for W push button, there are some signals like clicked, double-clicked, checked, or unchecked. And the slot is a function that is used to respond to a signal. It can be ordinary function, member function, or C++11 lambdas. So in order to respond to a signal, a slot must be connected to a signal. And in Witty, we use a member function called connect to connect a signal, which is here clicked, to a slot. So as you can see, there are three ways for doing that in Witty. One is simple Witty way, which you connect the clicked signal of the button to function that handles it like this. Another way is using the boost bind, which is practically the same, but you should use the boost here. And there is another option for those that interested in lambdas in C++11 that you can use it directly like this, but rather than boost bind, you should use bind, which is included already in the standard C++ library. And this is the lambda version of that. So here, the things that we are changing in our basic Hello World application is adding 3 more widgets. One is line edit, the other one is a break, and a text widget. And here we have 3 lines for the version that we are using the Witty or boost method. The rest of the things are the same, but in this slide, these are the additions that we have. Now in the constructor, we have more code here, and also we have another member function which is greet. And it responds to clicking the button. So as you can see here, we have another additional function call which is set title. We title the we change the title of the website to Hello World also, and we add a text first that requests the user for name, and then we have a line edit to enter the name, and we give it a focus, and then we put a button here which says greet me. And this greet me, by clicking on that, is going to show the text that we want. But here, as we can see, we can connect this to our function or the slot. But we should do it twice. One, when the function is clicked, here is called the greet function, which only just print the message hello there. And there is another one that we should do, because maybe user, rather than clicking on the button, press enter in the edit box. So we connect the same slot, which is greet, to that signal too. Here, compiling and linking is the same, but because we use the signals, we should also link with the boost signals library too. Here I have the application already compiled. So if I refresh the web server here, you see the results. As you can see, it asks username, please, and I can put my name and then click on greet me, and it shows the text hello there Armin. But it's also possible that user, after typing the name, just press the enter button that I do now, and as you can see, this is the second instance of that, and we have hello there here. So last thing that I'm going to show is the Lambda version. If you already know the Lambda in C++ 11, there are kind of ad hoc functions that you can put in a block, and it has access to all the variables in that block. So in this version, we don't need any member functions, and this part of code remains intact. And the only thing that we should do here is that to define our greet as a Lambda. But because we want to use this greet twice, one for this slot, this signal interpressed, and another for click, we define our Lambda as a variable and assign it to greet using the newly added keyword in C++ 11 auto. So by using that, we have our greet, and we bind this greet to these signals, and the output is almost the same. But in linking process, the only thing, the compiling and linking, we should add also support for C++ 11 if we want to use this version. So next thing that I wanted to cover was widget gallery, but I think we ran out of time because, but I already showed some of the things. The only thing that I'm going to show now before I end my presentation is the web gallery site that we have already seen, but maybe it's better to have it again. Okay. By going to this site, there is lots of examples of different widgets and also all the codes here. For example, if you want to show a dialog in your program, here is the code, and by clicking on jump, the dialog appears here, which only accept this kind of input, like A1 to Z99. So if I put something that is not acceptable, the OK button is not going to be enabled. But as soon as I put A1, for example, which is acceptable, OK is enabled. And you can see the whole sample here. For all these samples, you can replace or copy and paste this part into our boilerplate code that I show you in the whole world hello world example, and then you can have your application running. As you can see here in this sample, but maybe it's not really, the quality is not good, it also used the Lambda version to do that. There are lots of samples for different widgets supported by Witty, for example, sliders, progress bars, and with all the codes already included, that gives you a really head start working with Witty. Last thing that I'm going to say is that if you like the library functionality, but C++ is not your choice, there are some Witty variants. Java programmers can use JWT, a native Java version of Witty, developed and maintained together with the C++ version. It has the same features as Witty, but runs natively in Java virtual machine and can be deployed into any servlet container. And the other one is the Witty Ruby, which is a Ruby bindings to Witty, using the same framework used for generating Ruby bindings to Qt or Qt and Kodi. That brings us to the end of this webinar. I should mention that Witty is a really huge library. 1 hour is not enough to do this topic justice, and I had time to just scratch the surface. Thank you for your time. I'm ready for any questions, comments, or thoughts.